Hello, fellows. This is Engineer Vikas Ahmed, and with another oil and gas field project video, which is going to inform you that how to grip on your oil and gas field knowledge to make more accurate project planning and scheduling kind of things. So here you can see in the image there is equipment you can see, and before getting into the details, I will share with you. This is actually upstream field wellhead project installation. So this is you can see there is wellhead assembly, but I will be sharing whiteboard over here to make you more understand with this oil and gas kind of work so that you can have more knowledge about it. So let's say I'm talking about from reservoir. I'm not going into the details of reservoir. Let's say there is, this is your reservoir. This is your oil and gas. See, this is your oil and gas, and this is your top surface area. This is where you are living right now. You are okay. So everything. So this is actually field area. So through drilling, you got access to this area, and oil and gas field is going to flow from here. I'm just giving you an idea visualization how it will work. Okay. So this is drill pipe completion geometry. So on the top surface area, there is one equipment, there is one tool installed over here. This is called wellhead. It have different kind of valves like production valve, kill valve, swab valve, master valve. So this assembly is actually a different kind of thing I will be sharing. So when oil and gas is flowing up over here, it's going to flow different kind of like production lines. There are different kind of vessels attached to it, choke manifold, control station, which is controlling that one, ESD we can call it, and then knockout drums, then storage tank, then more production area, then to the refinery ultimately. So if we have a certain field which is going to have 50 such kind of wellheads, because in oil field, what will happen? 50 wellhead assemblies are going to connect one production line. You got my point? Okay. So I will be sharing this visualization of this wellhead, how it looks like in reality. So don't rely on my drawing. Okay. I'm not that much good designer. Huh? I'm good planner, but not good designer. So you can see over here, this is valve. Whenever we need to make, as a human being, if I'm sick, doctor going to ask me, okay, you need some examination, blood test and all that. Same is happening with oil and gas wells and reservoirs. If something not going well, so we need to run in hole from here. This is called valve, swab valve. This is production line valve. This is kill line valve. This is master valve. This is lower master valve. So different kind of purposes. But so this wellhead is going to attach with such kind of, you can say, assembly. See over here, these production lines, there are different kind of equipment involved. So you have an idea. But if I look into this picture, I can see that there is civil work involved. This is a foundation. There will be earthwork. This area is same like this one. See, there are herbs, shrubs, trees, not regular area for placement of these kind of vessels. So we need leveling, we need earthwork, we need some sub base, aggregate base, we need compaction, we need foundation concrete work. So a lot of civil works involved. Then on the second part, you can see there is piping works, there is vessels works. So these all scope of work we can document over here. Just give me a moment over here. See. So if I will let you know that how it's going to work for us. So majorly we have in oil and gas field, we have scope management. Once we are done with scope management, because even you are a planner, you are a scheduler, whatever you are, scope management is the key to success for a project planner. I can give you a guarantee. You can make building project planning, you can make road construction project planning, petrochemical, oil and everything if you are good with scope management, how to do that one. So you have project management team, but I'm going to give you an idea. So there are major, I'm not considering EPC because engineering procurement. I'm only directly jumping onto the construction phase because that is more involved with the construction or site oriented kind of things. Okay, you got my point. So I'm going to help you people how to maintain your scope baseline. So this is my construction. So majorly I have observed that there is a civil works involved, there is a mechanical works involved. And of course, to record, to document my scope baseline for this work, I need designs, I need to sit with the design engineer for that. I need to sit with my project management team. I have to, in oil and gas, it is very important to make site visits for a planner to visualize that thing personally. Okay, it's very important thing. It's not so site visits are very important. So after knowing all these things with our collaboration with our team and all that, SMEs, we can not forget this specific personnel. SMEs, subject matter experts, the people who are supervisors, foremen, coordinators, project managers. Okay. So after realizing this thing, we are going to make our project WBS. The major one is civil works and the second one is mechanical work. Same thing I'm going to document into my Primavera P6 and here we are. This is my Primavera P6 dashboard. I'm going to add, just make apologies. First, I have to go into the WBS and here we are. Kindly add this one, civil works, and then make over here mechanical works. We can add later on as well, like piping works, like instrumentation, but I have majorly divided it into two categories. It's not like a final verdict. You can ask your team, you can take the lesson learned, you can take your company OPAs, organizational processors, in which your company, how they are following that template. So as per this video, I'm giving you insights that how you have to get along with the project scope management development. But as per your company requirement, you can make more WBS as per your site conditions. Okay. So here, so I have to make maximize civil works. In my civil works, you can see there is a civil work involved for my constructional wellhead foundation. So I'm going to make over here, see civil works, subdivide it into like this one. Okay. And then I will make more headings like this, and one by one I will make copy, because along with it, yes, construction of tank foundation, you can already have witness about this thing, so it's already there. So make your, just give me a moment over here, see, and then over here I will share with you the Excel document and the construction of ESD control panel, emergency shutdown system. It will be always there for the safety reasons. And then again, I'm going to share with you the things like other civil works. Okay, this is miscellaneous. So another head under which other things will come up. So I need to add one more. And here we are. Okay. And again, I'll be sharing, see, what are the other site clearance and preparation, lay access roads, drainage, and other utility installations. Yes, that's one. Other civil works. So what I'm going to do, site clearance. This should be on top, by the way. This should be on top. Let me make it on top. We can move it. So just make like this, site clearance, because this is the first thing. Road access, because this is in remote area. Okay, so we need to make access that our teams can approach that area. And then I will be sharing with you lay access roads, drainage, and utilities. So this WBS is done with it, this one. So all these things are civil works. And then construct wellhead foundation. I'm going to share with you first mechanical. Just give me a moment. We are going to make mechanical works over here. See, a mechanical can be subdivided into this one, fabrication, wellhead. Okay, back in the yard. Our third party is going to work for that one. So I'm going to subdivide. No, not this one. This mechanical works. Okay. So like this way. And then I will divide this one more than this one. Then I will make for a one time, just sharing with you that what are the else. Install wellhead. Okay, after fabrication, install wellhead, and I will make copy. and I will be sharing. So this is the same activity you can do on Primavera P6 if you are already worker. So I will be explaining now these things one by one. Just give me a moment that you can do. I know that as per parent-child logic, you can do that one. Okay. So let me, okay. Civil works, I have already loaded over here. Okay, these all things. So mechanical works like this one, okay? Because first of all, I'm going to make fabrication of all my wellhead because I will be sharing over here the things just to visualize you what's going on. Fabricate a structural framework of wellhead because this wellhead will be not it will be manufactured in other company or it will be ready made and we are going to make by. Okay, so it depends on, but framework in which it will be secure safety because you can see. So that fabrication I'm going to talk about right now. Install wellhead because we are going to make on site installation. Then install production line, the production line which is going to connect with this one through which oil and gas fluid is going to flow and reach on some already storage tank or production line. Install kill line. Wellhead is having another valve over here which is called kill line. This is another operational thing in which we can say that kill line. What is the purpose of kill line? When our well is not working properly, we need to close this well or kill this well. Whatever oil and gas is coming up, we need to make over here. Like we make dead by the using of different kind of heavy fluid like brine. Okay, so for that purpose, we need another passage or another valve, that is kill line. Install choke manifold. I told you that how much fluid we need to permit to pass through this line, which is actually going to decide our reservoir life. So there is one choke, which is like this 1 inch portion. Okay, it can be half inch, it can be 1/3, it can be 1/4 of inch. So that is called choke manifold. Separator. When this fluid is going to move to refinery or some processing unit, there is one three-phase separator because we know that in the reservoir there are three kind of things: oil, gas, and water. So why it is called three-phase separator? Because it is going to segregate, it is going to separate that oil, gas, and water into three categories. So this function of three-phase separator is, so we are going to install, this is already ready-made things available in big companies which are manufacturers. In procurement, when we are going to make this project in procurement, we are going to assess when we need to order, this and when it will be available when our project is ready. Because when our this work package is ready, we need to install, it should be available on site. Then there are storage tanks from which this from fluid from this separator, water is going to the water tank, oil from this tank to go into the oil tank, and gas from this tank is going to the gas line. Okay, or flare line. Then see, oil line, flare line is actually gas line. Either we have option to flare that line to fire it up so that we can secure the environment, the area. If there is permanent solution, if there is permanent kind of project is going on, then we have to save it. If it is temporary, we need to flare it. Route planning and excavation, pipe welding and installation. Yes, pipe welding and installation will not be done on site if because of safety reasons. So we are going to make it off site. Connect to flare stack because connecting all these pipelines. Functional testing and safety. Obviously, we are going to make, if we are going to install this wellhead, we are going to make some safety pressure test. If we are going to install this production line, we are going to make welding test, hydro test, choke, everything will followed by recommended testing and all that. So these are the mechanical things. So under these mechanical kind of things, I'm going to share with you fabrication need design and engineering approval, cutting assembly, and this document, as per this document, you need to access install wellhead. This is the procedural thing, testing and commissioning. Then see install production line, layout, piping, route. You have to make sure that from which route this production line will connect from wellhead to the production area. Welding and assembly, pressure testing, everything install. So see, everything is given like this. But I think on major points you understood what to do. Okay, see, all these things are there. And even if you can request me, I can provide you this sheet as well. Okay, there is WhatsApp number given in my this video description area. You can message there and you can find such kind of things. And we are also offering complete industry based trainings using Primavera P6 and all that. You can also join that my webinar in which I will be explaining each and everything. This is only scope management I am explaining right now. What I am explaining, how to collect your scope. After this, what we are going to work on it, how to calculate time management for all these things. Then cost management. Then how many people or teams are going to work, resource management. After implementation of all these things, we are going to generate critical path method. We are going to produce S curves. We are going to produce progress reports. We are going to have different kind of quick features of Primavera P6, like recovery schedule, like resource labeling, cost account, cost code, resource code, many more things. So you can also enroll with me if you want to learn these things. And may see, I will be adding all these things one by one. See in Primavera P6 and how it looks like in activities. In activity window, it will be refreshed and it will look like this one. See, this was mistakenly added. So after this, what we are going to do, because we have a big list in our here, I have to maximize all the scope of work and I will make a detailed tour, like see, construction wellhead foundation, every civil work is there, concrete foundations, their ESD foundations, their other civil works, mechanic. So everything, this is called parent child logic. This will come under this see 3.1.1, 3.13. See, this is called hierarchical structure, parent child logic or node format of WBS. There are 3 digits, there are 4 digits, parent child. Okay, so you have to make such kind of WBS. Okay, like this. And getting back to Primavera P6, how it will now, the next thing, the most important thing, we have to make our project templates. The most important thing which people, before jumping, because why planning engineering is the most important thing, I will give you an example. Because your oil and gas field projects needs very accurate resource deployment. Even onshore projects, offshore projects, you need resource scarcity. You have very less resources to work on your sites, dangerous sites, not in terms of any other thing, but because expensive, costly, and very safety you need to require. Okay, so resource deployment is very important. Time safety is very important, because time is money. Money safe is very important. Okay, so this is the most important thing you need to carry in oil and gas field to secure good and high salary job careers. So these all things are relating to planning engineers. Planning engineers are the ones who are going to take care about these things. So that is why we need to learn planning and control. After doing these things, like scope management is done, we need to have time management. Okay, that how to manage your time. There is project management methodology, critical path method. Our major motive after loading scope is to reach on activity level. So how is the project template? First of all, project level. Then there is WBS level. WBS top level would be called control account. WBS mid level would be called planning package. WBS lowest level would be called